Well, joint moment generating functions can be used to generate moments, but you can also use them to find marginal moment generating functions. Here is an example. If you want the moment generating function of x1 alone, by definition, way back in chapter 3, the expected value of e to the t1 x1 is the moment generating function of x1. One way to find that, if you have the joint moment generating function, is to plug 0 in for t2 in that joint moment generating function, and that will give you the marginal. Likewise, to find the marginal moment generating function for x2, that's the expected value of e to the t2 x2, and you can find that by simply putting a 0 in for t1 in the joint moment generating function. This leads to a second definition of independence. Recall earlier that two random variables x1 and x2 are independent if the product of their marginal distributions is the joint probability mass function or probability density function. Well, the random variables x1 and x2 are also independent if and only if the joint moment generating function is the product of the marginal moment generating functions for all values of t1 and t2 where the joint moment generating function exists.